What is direction? Direction. What is direction of vector? What is direction of vector? What is direction of vector? Okay. Now, for surface, in every function there is some surface. The surface for the 2D and 3D. Okay. What is the 2D is a boundary condition. Boundary condition. In 3D, no boundary. Example of 3D is sphere. And here example is 2D plane and cart. For example, kapur. It is in Bangla language, kapda. Open surface or cloth. Open surface. Okay. This closed surface, I will say enclosed surface. Closed surface. Closed surface. What is going in closed surface? All the boundary strings to a point, and surface of 3D object is closed surface, but not always true. Surface of 3D object is closed, but not always true. For example, here the example. Suppose this is my cylinder. The upper point of the cylinder is open. Then it is open. Why? Because because there is open. I mean, if there is a space to enter in that function, that will be open surface. Okay. So this is open surface, and what can I read it? Write it in closed surface. Closed surface boundary. Strings to a point. Strings to a point. So that is true. If I write equation of plane surface, that will be ax plus by plus cz plus d equal to 0. This is for plane surface equation. Curved surface equation. What is curved surface equation? Phi function of xyz equal to constant. Closed surface equation, and this is closed surface equation. Closed surface equation will be phi xyz same like curved surface. Now direction of the surface, main thing what I want to say, direction of surface. Suppose there is a plane. Like this. So where is the normal, or where is the normal of this surface? What is normal? Is 90 degree. Normal would be 90 degree angle. Like that. Here you can say normal to the surface up and down. Both are equally probable. You can take any one. Both are equally probable. You can take any one. Okay. Now this is for our normal, and this is for plane. If I take a cube, where is the normal? There is 6 normal, because 6 surface. One is there, and other is here. So this is in the closed surface. Okay. Now, how many x hat, y hat, z hat, minus x hat? Here, x hat, I will write it, x hat, y hat, z hat, minus x hat, something like this. the second thing which I tell you, um, scalar in tensor tensor sorry, vector is a special case of tensor. Vector is a special case of tensor. So and vector rank 1 in tensor. What is scalar? What is scalar? Now, what is scalar? If tensor rank 0, tensor rank 0, physical entity having magnitude only, okay, its tensor rank 0, it remains invariant under parity transformation, rotation, reflection, which I previously tell you. Okay, pseudo vector, the vector like physical entity that remains invariant under parity transformation and rotation but changes sign under reflection. This is that will be pseudo vectors. So pseudo vector will be another time I would say the vector like physical entity that remains invariant under parity transform and rotation but changes sign under reflection. That would be pseudo vector. I mean, example is a vector cross b vector minus a vector cross minus b vector equal to a vector cross b vector. If a is vector, b vector, a vector change in parity transform, it will be change minus a vector. So here change sign but minus plus, then that is a pseudo vector. Pseudo scalar. The another is pseudo scalar. Pseudo vector. I tell now pseudo scalar. What is pseudo scalar? The scalar that type physical entity that changes sign under parity transformation, parity transform, and reflection remains invariant under rotation. It's called pseudo scalar. Like force charge into electric field, or you can say electric field force by charge. This is for the equation. Now I'll say what is the properties of vector. My main focus is vector. What is properties of vector? Look, this is I draw a line with the top of this arrow. Here, length of this vector is called amplitude, magnitude of the vector. The length of the vector is magnitude, and the arrow is denotes the direction of vector. Sliding of vector allowed, keeping in mind that magnitude and direction is same. Now vector fields and scalar I will tell you.